All right, now here's the reaching stuff. There is a lot of excitement in the technology world about other forms of solid state, not just flash. The one that is most real now is called phase change. And in phase change, what happens is that according to the rate that you heat and cool a material, it takes on a lattice or an amorphous structure as it cools, and they have different resistance. So you can program zeros and ones by controlling the rate that you heat and cool the material. That can be made quite small. It's called PCM for phase change. And it's already at approaching DRAM densities. Its costs are still too high, but then that's all about volume. This technology is interesting, particularly because you don't have to write in big blocks. You can write individual words. So in the 2020 era, at least phase change will be commonly available and used in lots of places. Some people would like to replace DRAM because phase change doesn't consume any power when you're not reading it. So it could reduce power considerably. The problem is that phase change wears all of these changes, and so it currently wears out pretty aggressively. So that might mean that DRAM becomes a two-tiered solution where the DRAM that doesn't wear out but is power hungry, and the phase change which does wear out but is power friendly. So these technologies are coming. We will, as they become commercial, the storage world, all of the vendors, will adopt them and use them inside our boxes. We like the idea that there are chunks of memory that are non-volatile and that you could recover from them after a crash or a power. So as they become very commercially available, it'll make sense. The most interesting one is called the spin torque tunneling or spin torque transfer MRAM, magnetic RAM. The reason this is interesting is, in short, what you do is you take a DRAM cell, you put a little bit of magnetic material in the middle of it, and then as you're writing bits into the DRAM cell, it orients the grain, the magnetic grain, and you can sense that again. All right? And so this can be as small as DRAM, and the really cool thing is there's a possibility that it doesn't have any wear problems. Just like magnetic disks today, you can write them a lot of times before there's any real damage. And so this one is the technology that's most appealing and furthest out. But if the STT MRAM happens, it will change the way we do main memory and the hierarchy.